Hello students and welcome back to my channel. This is the second video in continuation with the first video. Okay, in this video we will be discussing questions based on projectile motion and Newton's laws of motion. Here basically we are discussing questions which were asked on 30th of January 2024. 30th January 2024 JEE mains. So here comes the next question, question 5. You can see all surfaces shown in figure are assumed to be frictionless and the pulleys and the string are like the accretion of the block of mass 2 kg is. This is the figure, students. You can see the figure. Okay. We have to find the accretion of this 2 kg. So certainly this will come down, the heavier will come down and this will go up. So if we take the accretion as A, here the accretion must be A by 2. By simple constraint relation you can see, students. For example, if suppose this pulley comes down by 1 meter. So here there is an increase of 1 meter of length and here also there is an increase of 1 meter length. So total increase in length is 2 meters because anyway here it is fixed. So that length should come from this side. So it has to travel up the incline, a distance 2 meters. Are you getting this point, students? If this pulley happens to come down by 1 meter, there is a 1 meter length here, increase in length, and here also there is an increase by 1 meter. So altogether 2 meters increase. So that will come from this side, hence the block has to climb up the incline by distance 2 meters. So that's why what will be the displacement of this 4 kg mass down? The displacement of the 2 kg mass will be just the double in the same time. So naturally velocity will also be double and acceleration will also be double because it happens in the same time. So that's why if I take the acceleration as A for this block, we have to take the acceleration as A by 2. Right, students? Then in the free body diagram this will be 2g sin 30 degree. Sin 30 is half. Also in the free body diagram with the tensions, and here it is 4g. So for this block I can write, taking the acceleration as upward in the positive direction, I can write T minus G is equal to 2A. Similarly here, taking this direction as downward direction as positive, I can write 4G minus 2T is equal to 4 into A by 2, or 2G minus T is equal to A dividing 4 by 2. Okay, since we are interested in acceleration of the block, let us eliminate T. So adding equations 1 and 2. Adding equations 1 and 2, you can see plus T minus T gets cancelled. 2G minus G is G, and here it is A. Therefore A is equal to G by 3. So G by 3 is the answer. So we will go with the second option, students. Then moving to the next question. The particle is placed at point A of a frictionless track ABC as shown in figure. This is the figure, students, you can see. It is gently pushed towards right. The speed of the particle when it reaches the point B is. I am sorry, students, this question is from the next chapter, that is work energy power. So by mistake I have taken this. Anyway, we will proceed with this. So we have to get the speed of the particle at B. It is released from this point by giving a gentle push. Negligible push means its speed was 0, initial speed. We have to find the speed here. Now in these kind of questions we have a direct formula, students. When a body slides down along a frictionless surface, whatever will be the nature of the surface, I mean whether it is uneven or even, it should be smooth. So there will be no energy loss. Okay, so we can always apply law of conservation of mechanical energy, in the sense that loss in potential energy will be equal to gain in kinetic energy. In all such equations we can write V square is equal to U square plus 2GH, where V is the speed here and U is the speed initially. So the initial speed is 0, students. So therefore we can write V square is equal to 0 plus 2GH. Therefore V is equal to simply root 2GH, where H is the difference in height between A and B. Difference in height between A and B. So this will be 2 into G is 10, H is also half, you can see. From 1 meter you deduct half meter. So 2 gets cancelled, we are left with 10 meters per second. So we'll go with option 2. Notice student that instead of writing half as h, I have written, instead of writing 0.5, h equal to 0.5, I have written it as half. So immediately you can see I could cancel 2 and 2 and whatever is left is 10. So a simple suggestion, always try to avoid decimal and try to proceed in fraction because that facilitates cancellation process. So always try to proceed in terms of fraction rather than decimal. Then moving on to the next question, that is question 7. A block of mass m is placed on a surface having vertical cross section given by y equal to this much. You can see student this is a parabola, equation of parabola. Okay, y equal to 4x square into constant with origin on the ground and x-axis being the horizontal. If the coefficient of friction is maximum height above the ground at which block can be placed without slipping. So this is very simple question students. This is the parabola. Parabola will be like this. Suppose this is a point where it is kept. Now you can treat the tangent as an inclined plane with angle of inclination theta. Okay, then if it is the maximum height above which the block can be placed without slipping. So this is on the verge of slipping student. Then this should be angle of repose. This should be angle of repose if the block is on the verge of slipping. And in that case we know that tan theta is equal to mu. But tan theta is equal to slope of the curve student. So slope must be equal to mu. So if slope is dy by dx. So dy by dx is equal to mu. Mu is 0.5. I write it as half. So when you differentiate this, you get 2x by 4 half. So x is equal to 1. Okay students. So when you put x equal to 1 here, you get y is 1 by 4. Because in this point, if you are getting x equal to 1, y will be x square by 4. So 1 square by 4. So 1 by 4. We go with option 1 by 4. Right students? Then moving to the next question. 3 blocks A, B and C are pulled on a horizontal smooth surface by a force of 80 Newton as shown in figure. The tensions T1 and T2 in the string are respectively. You can see students this is a figure. Okay? There. Now we want T1 and T2. The most easiest method is this. As you can notice very clearly that all the 3 blocks will be having common acceleration. The acceleration of all the 3 blocks will be common. So let us find the common acceleration. So common acceleration can be obtained as force upon total mass because all the 3 blocks together will be moving. They will be moving together as a single body. So the only force in the horizontal direction is 80 Newton, whereas sum of all the masses is 10 kg. So the acceleration is 8 meters per second square. Is it students? So each of the 3 blocks will be moving with this acceleration. Right. Then if you want to know T1, let us draw the free body diagram of A. As you can see, T1 is the only force acting on the block A. So apply Newton's second law, I can write force is equal to mass into acceleration. Mass is 5 kg, acceleration is 8 meters per second square. So T1 is 40 Newton. Right students? Then we require T2. Let us draw the free body diagram of this entire part. So taking the entire part as a single body, the only force responsible for the movement of the blocks to both the blocks together A and B is T2. So rewriting this as T2 as m into A. So mass will be 5 kg plus 3 kg, that is 8 kg. Acceleration is 8, so this is 64 Newton. So T1 is 40 Newton, T2 is 64 Newton. We go with option 1 student. Right? Then question number 9. Projectiles A and B are thrown at angles of 45 degrees and 60 degrees with the vertical respectively from the top of a 400 meter high tower. If their times of flight are same, then the ratio of their speeds of projection VA is to VBs. Now students, it's very simple. Suppose there is a tower. This is a tower. Okay. Now, if anything is, projected, then the time of flight will be governed only and only by two things: the height, okay, the height from which it was released, and the vertical component. Vertical component. These two things will decide, because acceleration due to gravity is universally applicable to all the bodies, regardless of its size or shape or mass or whatever it is. So that means if their times of flight are same, and they are already, they have been projected from the same point. So h is anyway same for them. So it means that the y component, that is the vertical component of velocity, should be same for both of them. So automatically their times of flight will be same. So for the first one, velocity is va, and it makes an angle 45 degree with the vertical. So that means its vertical component is va cos 45 degree. Similarly, for the second one, its velocity is vb, and it makes 60 degree angle with vertical. So its vertical component will be vb cos 60 degree. So both should be same. Their vertical component should be same, students. So va is to vb is 1 is to root 2. Okay, students, this root 2 gets cancelled here. So we'll go with the fourth option, 1 is to root 2. Then moving to section B, a vector has magnitude same as that of vector A equal to 3 I cap minus 4 j cap and is parallel to vector B equal to 16 I cap plus 12 j cap. The x and y components of this vector in the first quadrant are x and 3 respectively with axis. Now as you can see, students, this is very simple. Okay. Now the first thing what it comes to our mind is, let us say that the new vector is C. So if vector C is parallel to vector B, then I can write vector C as some coefficient, let us say k times vector B, where k is a constant. So vector B is 16 I cap plus 12 j cap. Okay, students. So I have k into 16 I cap plus k into 12 j cap, of which it is clearly given that the x component is x and y component is 3. So this is 3, students. So 12k is equal to 3. So what is k then? K is equal to 4. So therefore, looking at the y component, if y component is 16k, k is 4. Sorry, I'm sorry, students. K is 1 by 4. K is 1 by 4. So therefore, 16k must be equal to x. So k is 1 by 4. So x must be equal to 4. Okay, you can see that only the x and y components have been numerically interchanged. So our new vector as per this is 4 I cap plus 3 j cap. And as you can see, each of the two vectors has a magnitude 5. So x will be 4. Alright, students, that's all, students, in this video. Thank you so much for watching my channel. Kindly subscribe to it and hit the like button. Thank you.